people from the future.
This
So-
is 2020.
Nobody's ever going to watch
Class
this.
of 2021.
What a waste of time.
Probably on the calendar yet.
Maybe you'll have fans in the future.
That's right. Or people will be trying to dig up things to make me look bad. Flaccido. I bet you could totally take these videos and like...
I could send this next year to say something really bad.
Exactly.
Oh, yeah.
Okay. Do you think the chain rule will work for integrals? What do you think, everybody?
Yes. Yes.
No.
How many
That's
people
what we're gonna learn
say?
today.
How many people say yes? How many people say no?
I'm just hoping it's
Because I
not.
want to wish
I wrote probably with a frowny face.
It's probably yes.
Well-
Because we'll be learning this.
No worries, because Placido and Inder are correct.
Hey.
The chain rule does not apply to integrals. We've got something even better.
Oh, even
The anti-chain.
you mean even
The combo.
For instance, yeah, let's say I like combos. I like the pizza flavored ones. Say we have the integral.
I wish we were doing chain rule instead.
It's kind of like, it's the chain rule equivalent for integrals, but it is a different fundamental process. You guys are going to love this one. You're totally not going to believe that this is something you can actually use. And we'll find out at the end if it is or not. But you're going to take notes anyway. So, if this is true, and we want to solve that integral, we need a way to do it, because we can't do it using our regular integral knowledge. We've got something that is inside of this entire function. So there's got to be some way that we can take that and make it into something that's manageable. So, as I'm kind of in the habit of doing, I'll give you the mathematical solution, and we'll see if you guys can make sense of it, and then I'll just go through some examples.
Real quick, what should we label our notes?
I don't want to spoil it yet, because that'll spoil what the rule is. Now, obviously, the way to solve a problem like this is to just do this. Duh. You just turn all the letters to the letter U, and then you solve.
yes.
Man.
One of them
Jake
says that.
Brandon was telling me about this.
Oh, gosh. Yes, it does.
Whoa,
So-
whoa.
Yeah, this is a rule. Any guesses on what the rule's called?
The
Oh,
unique
no.
rule.
You could probably figure this out.
The
Called the
unique
chain
rule.
The
rule.
U rule?
Yeah, basically, it's called, and this is what you can title your notes, u-substitution.
Oh, that makes me uncomfortable.
Yeah.
This is a joke made by the mathematicians of old
Does it make
because
you
they
more
knew what was
comfortable
going to
if the N
happen.
was actually an upside down U at the end
There we go.
What if the U with being is upside down?
What's that?
I just put it in all directions.
Okay. Sounds fun.
Okay. So, basically, this is what you're doing. You're taking out the complicated stuff, and you're going to put in the letter U instead, and then you're going to solve.
It's very complicated.
All right. So, let me sum it up even better here. Remember the chain rule? We have inside functions and outside functions.
Yeah.
Basically, what you're going to do is you're going to take the inside function, turn that into the letter U, and then solve. Now, when you do this, there's a lot of little things that you kind of have to keep in mind. So as I go through these examples, make sure you're paying good attention, and if you have questions, be sure to let me know. So what's the inner part of this function up here? Yeah, x to the fourth plus 2. So I'm going to set u. You know that it's bad enough when math starts turning from numbers into letters, but you know it's really bad when the letters that are there have to be turned into different letters. So u is going to be equal to x to the fourth plus 2. The next step that you have to do, and don't ask questions as to why, because it's just something we got to do, and you'll see why after the entire problem. It'll be easier to explain it. The next thing you got to do is take the derivative of what you decided to call the letter u. So the derivative of u with respect to x is going to be 4x cubed. And we're not done yet. We have to... Did I hear it? No, because we're taking the derivative here. Yep. So that's the derivative of this function. Now we also have to solve for dx. We would have to get this by itself. And if we do that, it's like we would, we'd have to put the 4x cubed down here in the denominator, divide both sides by 4x
You're
cubed.
talking about cross multiply?
Yeah. And then we'd have to pull out this dx and multiply both sides by dx. So dx is just going to be equal to 1 over 4x cubed du. So it's like saying this is something, and this is something. We got to solve for this guy down here. You're treating this as it's something you need to solve for. That's what that's about. Yep. Where'd you put my class? Down here. There you go. Questions on how we reached this location? We're not taking questions as to why yet. Okay, so that's where we are. Now we got to take this and we got to put it back in the original function, and hopefully that makes our lives easier and it gives us something we can solve. So this is now the letter u, and we solved for dx, so this dx is going to turn in to this. So writing this function again, x cubed times the cosine of u times 1 over 4x cubed du. Now you can start to see why we had to do this. Because if we're going to change this to the letter u, we're essentially changing what we're taking the integral with respect to. So then we can't leave this as a dx. We have to change this dx so that it is now in terms of the letter u. And that's what we're doing right here. So when we took the derivative, we got dx down here in the denominator. When we solved for dx, we got this, thereby getting that part of the equation in terms of the letter u, making this legit. So that's where we are right here. And this is where things get nice. So there's an x cubed on the bottom. That cancels with the x cubed on the top. We've got a 1/4 here. We can take that 1/4 and we can throw it out in front of the integral. So now we've got something we can actually solve. What's the integral of cosine?
Negative sign.
Almost.
Oh. It's a sign.
Regular sign, yep. So the integral of this is going to be regular sign. And then the final step of this whole thing is to put back in what we originally took out as the letter u. So your final answer would be 1/4 times the sine of x to the 4th plus 2. I hope that's the answer. Yeah.
Okay, I'm very confused.
That's okay, because we're going to do 3 more examples. This is the sort of thing that you can only get used to by doing examples. So I'll walk through this one step by step once more, and then we'll do 3 more, and hopefully by that time you at least get a little bit of the hang of it. So step 1 is to, actually why don't I give you the handout first. This is a difficult thing, so what I did is I typed out as best I could a little summary of what we're doing.
Thank you.
Mm-hmm.
I'll start taking notes
There we go. All right. So basically, the idea here.
Are you okay?
You okay, fine?
Stay calm, guys. It's okay. That's example 1.
Yep, that's the easiest one.
Yeah, you already make
Wait,
them
you're
as
kidding.
crazy, right?
I know, this is like the worst day for this, isn't it? On a Friday?
We're all done already, and then there's just a lot of stuff going on.
Yeah, I know. I know.
Symmetry, baby.
So let's just go through the page just real quick together. The idea is to replace a complicated integral with a simpler one. We do this by changing the original variable x to a new variable u, and that's a function of x. So we're substituting out something that's complicated, that would be the inner function, and we're turning that into the letter u. So basically, recall the chain rule for derivatives. Under most circumstances, u is going to be the inner part of your expression. So when we talked about chain rule, and you had your inner function, 90% of the time, that's going to be what you need to change to the letter u. So that's step 1. Yes?
So how do you determine which part is the thing?
Well, it's usually in parentheses, or it's under a square root or something like that. It's the sort of thing you just got to kind of develop the feel for.
So pretty much everything can be insane.
Yeah.
So if that's the case, x cubed cosine could be the inside part too.
Well, no, because, I mean, the inside of this is whatever's
Yeah, yeah.
inside the trig function. Typically, it's either in parentheses, it's under a square root, it's the exponent of the e. That's a lot of sometimes your inner function. But when you do more examples, you kind of get a better feel for what you're going to choose for that.
So like pretty much 99%.
Mm-hmm. And if you pick wrong and it doesn't get you anywhere, then you just try something different. So, yeah, the rest of the page just kind of goes through some troubleshooting. What I really want to do is I just want to do some more examples. But again, it's the same. The cool thing about this is it's the same procedure each and every time. The only thing that you're doing different when you're doing these problems is you're picking a different letter u. You're picking something different to set u equal to. Once you do that, everything is just step by step a procedure. And so it's just getting used to that procedure. So let's do the next one. So even though this sounds kind of like a made-up, weird way to actually solve problems, it does work, which is why I teach it. We didn't use blue yet.
It's the voice in your head. Good choice. That's good.
All right, there's our function.
That's worse.
You guys ever watch sorting algorithms on YouTube?
So
It's so weird.
What do you suppose we should set the letter u equal to here?
2x plus 1 1/2.
2x plus 1. It's underneath the square root. It's kind of like an inside function. So that's what we're going to set u equal to. So if u is equal to this, the next step in this procedure is to solve for the derivative of that. So I would say du by dx. In other words, the derivative of u with respect to x is going to be equal to something. What's the derivative of this?
2.
Yep. So, if that's true, what is dx going to be equal to if I wanted to pull this out?
2 du.
Not quite.
1/2.
No. 2 du over 2.
Yeah. Let's just quick do this the long way to make sure everybody's on board. So if I want to solve this for dx, the next step would be maybe multiply both sides by dx. So then I'd have du equals 2 dx. And then if I want to get dx by itself, I got to divide both sides by 2. So then that would be du over 2 equals dx, or 1/2 du, however you want to write that. But you're just taking this and you're solving for dx each and every time. And it'll always end up being the inverse of whatever's out here. If you want a little shortcut, it'll always be, 1/2 du. If this was, 7x squared, it would be 1 over 7x squared du. It's always going to be the inverse. So dx is equal to 1/2 du. And now, any questions up to this point? Aside from just getting used to it. Alright, so now we've got it all set up. Now we just got to take this information, put it back into the original integral, and hopefully it looks a little bit prettier for us. So, I'll change colors. So, integral of square root of u multiplied by 1/2 du. And again, we have to do that because we can't just have a dx in here. We've already changed our variable, our inner function, to the letter u. So we have to take our integral with respect to that letter, which is why we have this 1/2 du here in place of dx. That is its purpose. It makes the whole thing legitimate. So an easier way of writing this, we could do two things. I would move the 1/2 out in front, because we can do that. And I would change the square root of u to u to the 1/2. And this is something we can totally do. When you take the integral of u here, we got to add 1 to the exponent, bring the inverse out in front. So adding 1 to this, I would have to add, 2 over 2. So 2 over 2 plus 1 over 2 is 3 over 2. So I'm going to have 1/2 u to the 3 over 2. And then I have to take the inverse of this and pull that out in front. And that'll be 2/3 then.
Wait, why can't you times u to d? They're different things.
Here? Well, we're not multiplying. This is essentially telling us what we're taking the integral with respect to.
So where do you divide by the 2?
Here?
You add 1.
Yeah, I'm adding 1 to the exponent, because that's what we do for integrals. We add 1 to the exponent
Yeah.
and bring the inverse down in front.
No,
So, a little bit of simplification. 2 over 6, so that's 1/3 u to the 3/2. So then the final step is to plug in our u back in. So that's 1/3 2x plus 1 to the 3/2.
So the du is just gone. It's not there.
Yeah, once you take the integral, it disappears.
Okay. Oh.
Just like if this was a integral that we could solve, the dx would disappear when we finish taking that integral. Like if we've got integral of x squared dx, the answer is 1/3 x cubed, and the dx just goes away. All right. Questions on the procedure? All right, let's do 2 more. Yep, I got one with E loaded and ready to go. That'll be the last one we do. What color should I start with? Red. Sounds good. This one looks so unfriendly. What's that?
Nothing?
That's right, I'll just watch it back and listen.
That's fine.
Nobody can hear. So.
It's a good.
Oh boy.
Now again, when you see these problems, try not to be intimidated because you're not going to solve this problem. You're going to make it look easier. And you're going to change it so that it's much easier to take care of. What do you think we should set equal to u? You guys have good instincts. So let's see where that takes us. I'm going to take the derivative of u with respect to x. Same procedure. What's the derivative of this?
That would be
8x.
Negative 8.
Yep. So if I got to solve for dx, my answer is going to be the inverse of this.
1 over.
Yep. Questions so far? Good. This is like the toughest part. The last part is taking this information, putting it in, and solving the much easier integral. So, let's do that. New color, what should I use? So our new integral is going to be x divided by the square root of x. Oops, u. See, look at you guys. You guys are on your toes. And that's times dx, which is equal to negative 1 over 8x. And look at this. This is going to turn into something we can solve. This x down here is going to cancel out with that x up there. I'm going to take this negative 1/8 and I'm going to throw it out in front. And of course, 1 over square root of
That
u.
would be u to the negative 1/2.
Yep. So now we just got to solve. If I'm going to add 1 to negative 1/2, that is going to be positive 1/2. So, yep, and I'm going to multiply this by 2, because the inverse of 1/2 is 2. And that's all it is, isn't it? So 2 times 1/8 is 1/4.
Negative 1/4.
And then you just plug in your value for u.
And then solve, obviously.
Don't solve.
Don't worry, I'm pretty sure we'll get that.
There's that. Yep.
Okay, I kind of agree.
Uno más.
I have no idea what you're talking
One more.
about. Thank you for your translation.
So this will be our E example here. So there we go. What should we set u equal to? Sounds good to me. Derivative with respect to x is going to be 5, of course. And so that means when we solve for dx, it's just going to be the inverse of that number. So we've got 1/5 du. And now we throw that all in for an easier integral. And I'll just pull the 1/5 out in front, I think. So in the same way that when we take derivatives of e to the anything, the answer is e to the anything, same thing's true here. Integral of e to the u is e to the u. Yep. And plugging in your u value, then you've got 1/5 e to the 5x.
Whoa.
And that's how u-substitution works.
Whoa.
So it goes from e to 5x to 1/5 to 5x.
Yeah. It's a small change. You can kind of see how the chain rule sort of works in reverse here. So,
Very nice. Very nice.
all right. I got some homework then, and remember this homework is your virtual day homework. Just take a picture of your answers, upload it to that assignment in Schoology, and you'll be set to go. How many of you guys are going on senior retreat? Nice. Have fun.
Yeah, can I send mine in 144p then?